Hello and welcome to this video on Python Standard Library. This is part 16 and we will read through most of Standard Library. We will not cover everything, but we will cover more than 90% of the Standard Library. So if you are new to the channel, please subscribe. You see that when we produce content on YouTube, particularly educational content, we don't get many subscribers. If it would have been an entertainment channel which would be involved in gaming or music or songs or some sort of roasting channel, then the number of subscribers is it increases very high because the number of viewers of those types of videos is very high. But for educational channel, the number of viewers is very less, so it would be of great help if you can subscribe to the channel. In any case, uh, watching this video is enough for me because if you watch the video and you get benefit, I'm more than happy. So without further ado, let's get started. So we were looking at immutable sequence types. So the description says that the only operation that immutable sequence types generally implement that is not also implemented by mutable sequence types is to support for hash built-in. The reason is that immutable sequence types can be used as keys in dictionaries. This support allows immutable sequences such as tuple instances to be used as dictionary keys and stored in set and frozen set instances. Attempting to hash an immutable sequence that contains unhashable values will result in type error. So if you are writing your own class of immutable type, then make sure that you implement hash so that it can be used as a dictionary key. Mutable sequence types. The operations in the following table are defined in mutable sequence types. The collections.abc.mutable sequence. ABC is provided to make it easier to correctly implement these operations on custom sequence types. In the table, S is an instance of mutable sequence type. T is any table object and X is an arbitrary object that meets any type and value restrictions imposed by S. For example, byte array only accepts integer that meets the value restriction 0 to 255. So operation is si is equal to x. So for example, we can have L is equal to 1 comma 2 comma 3, and we say that L0 is equal to say 5. Then if we print the list, it will be updated. So this is si is equal to x operation, print L. So it will become 523, which we can verify by running this program, python space lib12.py. So you see that it has been correctly updated to 523. The second operation is a slice update. Slice of s from I to j is replaced by the content of the iterable t. So for example, we can say that L 0 colon 4, or a better way to write this is L length of s, that is the entire list, and we want to update it by say 3 comma 2 comma 1. Then we can verify this. Oh, not SL. Sorry, my bad. You see, it is updated with 3 to 1. If you want, you can update it with a even bigger sequence. Let me zoom it for you. Yeah, that's much better. So you see, the entire sequence is updated. Next is delete the slice. Okay, so we can say that del L. Let's say we want to delete 2 elements. The first 2 elements will be deleted. You see, 3 and 2 are deleted. Del ij colon k is equal to t. So this slice is replaced by t. So this is interesting one. So let's first remove this. So now we can say that L 0 colon len L, step we give 2, sorry, colon 2 is equal to 5 comma 6, we should use different values, 6, 7, and maybe 10, 11. There are 5 elements, right? So 321 will 321 319 will be deleted in this. Let's see. Okay, 319, yeah, 319 are deleted. You see 6, 7, 10 took its position. So that's how you can do the slice operation. Similarly, you can delete like this. Append extends the array. For example, let's see this. So we have to append. So L dot append, say 4. It will become 1, 2, 3, 4. And let's say we append a list 4 comma 5 comma 6. Then it will become 1, 2, 3, 4, 5, 6. The list is added at the end. If you don't want to append as a list, you can say 4, 5, 6. Oh, it takes one value. So either you can append a list or append one item one by one. It will, you can try this. Maybe we can put a star and that should work out. No, it will take only one argument. So giving star makes it 3 argument. So either you increment one by one or you add a list. So we can say L dot append 5, L dot append 6. So it will become 1, 2, 3, 4, 5, 6. Yeah. Then we have clear. It will remove all the items. Copy will copy, make a shallow copy of S. Extend T. It will extend with S with the contents of T. So the function I was looking for was extend, not append. So you can say, oops, why I pressed a shortcut. So we can say L dot extend, and then we can give it 4 comma 5 comma 6 and it will work out. Yep. So we have append, clear, copy, extend. Then you can say S multiplied is equal to n, so update sets with contents with its contents repeated n times. S dot insert I comma x at certain position or index I, you put x. Pop is remove element at the item at the index I and also remove it from S. Okay. S dot remove x, remove the first item from S where Si is equal to x. S dot reverse reverses the items of S in place. So the nodes you can observe 1, 2, 3, 4, 5, 5 and 6 are applicable. So note 1 says that T must have the same length as the slice it is replacing. So this is for the slice operation. Otherwise there will be error. The optional argument I defaults to -1 so that by default the last item is removed and returned. So this is for pop. So by default last item would be removed. Okay, I defaults to -1 here. Remove raises value error if x is not found in x. So you have to be careful about this, that it can raise an exception. The reverse method modifies the sequence in place for economy of space when reversing a large sequence. To remind users that it operates by side effect, it does not return the reversed sequence. Okay, so you see that it will not return it. It is invoked on the table, and then since it is in place, it does not return anything. Clear and copy are included for consistency with the interfaces of mutable containers that don't support slicing operations such as dict and set. Copy is not part of the collection.abc.mutable sequence ABC, but most concrete mutable sequence classes provide it. Point number 6 is that the value n is an integer, an object implementing index or an object implementing index. 0 and negative values of n clear the sequence. So when we are repeating the element, you have to be careful that you don't give 0 or negative value, otherwise the sequence will be cleared. Items in the sequence are not copied, they are referenced multiple times as explained for S into N under common sequence operation. This we have already discussed. when we were dealing with the repetition, there was a program where we had a list and we said list dot append 3, and those three lists had the same member, that is, it was the reference, it was referenced, not copied. If you want, you can see this example again. The example I'm talking about is this example which we studied, that there's an empty list, you multiply by 3 and then you say append 3, then 3 goes at all the places. But if you want to put different values, then you have to use indexes, and then you say append 357 like this, and then they will take different values. So now we come to the sequence type list. So lists are mutable sequences typically used to store collections of homogeneous items, but lists can store heterogeneous items as well. So the class list iterable. So you can see that this gives a way how to construct a list. That is in this declaration kind of form. So this gives you this fourth type of construction mechanism. The first is by using empty list. The second is by square brackets separated with comma, the one I am using right now. The third is comprehension, which we have discussed in earlier videos, and the type constructor. The constructor builds a list whose items, hang on, let me see if video is being recorded here. The constructor builds a list whose items are the same and in the same order as a table's items. A table may either be a sequence, a container that supports iteration, or an iterator object. If a table is already a list, a copy is made and returned similar to a table colon. For example, list ABC returns A, B, and C, each as a string, and list 1, 2, 3 returns 1 2, 3 in brackets. If no argument is given, the constructor creates a new empty list. Many other operations also produce lists, including sorted built-in. Lists implement all the common and mutable sequence operation. Lists also provide the following additional method, which is sort. This we have discussed earlier with sorted. When we discussed sorted, we have discussed the list.sort in quite a bit of detail, so I'll skip this. In sorted, you should see my previous video where I have discussed the built-in functions, and in built-in functions sorted is discussed. I do not remember which video contains it, so you'll have to go through the list and you can quickly find out. It is one of the older, probably part 10 I believe, or 11th, like that. So we were discussing this, we were discussing list. Okay, so yeah, so we will not discuss this. We discuss tuples. Tuples are immutable sequences typically used to store collections of heterogeneous data, such as the two tuples produced by the enumerate built-in. Tuples are used for cases where an immutable sequence of homogeneous data is needed, such as allowing storage in set or dict instances. So the way constructor is defined is class tuple iterable. So it can be constructed in different ways. Use a pair of parentheses or use a trailing comma for a singleton tuple. If there is one member, you use a trailing comma. Separating items with comma like A, B, C, A, comma, B, comma, C. Use the tuple built-in tuple or tuple iterable. The constructor builds a tuple whose items are the same and in the same order as a table's items. A table may be either a sequence, a container that supports iteration, or an iterator object. So much like much like list, tuple can be created. If a table is already a tuple, it is returned unchanged. For example, tuple ABC returns A, comma B, comma C, and tuple 1, 2, 3 returns 1, 2, 3. If no argument is given, the constructor creates a new empty tuple. Note that it is actually the comma which makes a tuple, not the parentheses. The parentheses are optional, except in the empty tuple case or when they are needed to avoid syntactic ambiguity. For example, fabc is a function call with 3 arguments, while fa, comma b, comma c is a function call with the 3 tuple as the sole argument. So from this we can infer that a list can be converted to tuple and a tuple can be converted to list, which is quite common operation when you are writing code, because sometimes you would want to modify the tuple, but you can't modify the tuple. So you convert it to list, you modify, and then you convert it back to tuple. So that is quite frequent operation when we perform the real world programming. So for heterogeneous collections of data where access by name is clearer than access by index, collections.name tuple may be more appropriate choice than a simple tuple object. You'll see this when we reach there. Ranges we have discussed in great detail when we studied range, so I will not repeat that here. Okay, we have studied range in quite a bit of detail, and we have used range many times, so it's pretty simple to understand. So I will stop here, and in the next video I will take up str and we'll go through its functions, because there are lots of functions, so I want to cover str in its own video. Okay, so I'll stop here. I hope that you are finding this read through useful, and if so, please like the video, share on social media as much as you can, and let me know what you think of this read through in comment box. Thanks a lot for watching. Happy programming.